Okay, so as we start to make our prediction, I just want to call your attention to a feature of the classification algorithms in scikit-learn. If you remember here, when we made our actual predictions to validate our model, we ran this script, we got this hard distinction, right? Things were either red or blue, and this matches how our data came in. But what's interesting is the classification algorithm actually draws this line, and you can either ask it to predict whether it's red or blue, or in our case, where we really have some data which is mixed up and unclear, right? Or some data which is very strongly and clearly red and blue, you can actually ask the algorithm, instead of making that hard classification prediction, you can ask the algorithm to tell you the distance of the point from this line. Okay? And this is a way of doing a prediction that's more about probability. You say that, well, if the instance, the data point is very close to the line, it might say it's red or blue, but we're not really sure, because of the nature of our data set, it's not completely certain that it's one of those categories. But if the data point's way out here and it's very far from that distinction line, then it's very probable that it's red. Okay, so we're kind of equating the distance from the prediction line to the certainty of that value. Okay, so just to show you how that works, I'm going to go back to this third script, and instead of the prediction, I'm just going to change this to the distance function. Okay, this is a different function in the model. One is to make that hard prediction, and the other very useful function is this decision function. So it's the same exact setup, but instead of making a prediction, we're just asking how far away is it towards the positive and the negative side of that decision line. I'll run this again. So here we're plotting out the result. Here's our figures. This is our input data, and here's our output. You see what it did now is, instead of just having two categories, it has this gradient, right? It has some features that are very close to the line, some features that are very far away from the line in the positive direction. So these are things that are very certain to be from OCT, and some features that are very far in the other direction from that prediction line. Okay, so what I'm saying in this case is that because there's this uncertainty, in this particular case, it's worthwhile to use this actual decision function instead of the hard prediction to specify which points are likely to be in OCT, or likely to represent OCT the best. Okay, so that's what I'm going to use here instead of that prediction. Okay, so once I've scaled and transformed my feature data, I'm going to have this variable for my prediction. I'm going to call up my model, which I imported above here. I'm going to run the decision function on my scaled feature data. This is going to give me a basic prediction, and just make sure that these two variables match. This is going to give me a basic prediction from my model of this particular comment, and in this case it's going to give me the distance away. So the higher the number this is in the positive direction, the more certain I am that it belongs to the OCT category, and the higher this number is in the negative direction, the more certain I am that it belongs to the outside OCT category.